Hey guys, hey, that's the third video. Hopefully with only 6 slides, we'll make it through this time. Your natural logs work exactly the same way as your base 10 logs, your common logs. When it says what is 2 ln 15 minus ln 75, natural log, both of those. Then if you're writing it as a single power, you would rewrite this as natural log 15 squared minus log of 75. And that's going to give you ln 15 squared over 75. So you'd end up with 225 over 75. And actually 225 divided by 75 is just a 3. So that's where they give that. That's where they get that. But it behaves exactly the same way as the common logs. What is each expression written as a single natural log? Well, exactly like we did before. We've got that ln 7 plus ln 5 squared. So you'd have natural log of 7 times 25, right there. And if you got 7 quarters, you got $1.75. So there you go. That would be your final answer. Okay. This one, that 3 is going to come back over. You're going to get x cubed minus, now this whole thing is going to be squared. You're going to have ln x cubed minus this 4x squared. And it will be divided. You will have x cubed on top and 4x squared on the bottom. Your x squared will cancel out, and you'll be left with ln of x over 4. And this one, ln x cubed plus ln y squared, because these all have to come back over so we can get them together, plus ln 5. So when you multiply them all out, you'll just end up with 5 x cubed y squared. Okay? Now, these are ones you have to pay attention to because this one actually forces you to use the properties. It's a log base b, so you can't go to the calculator and put it in. I don't tell you a number to put in the calculator. So you've got to use the properties that you know and break these things down so that they're either a 2, a 3, or a 5. So log base b here of 4, well 4 is 2 squared, right? So we're going to put the 2 out in front, and you'll get 2 times the log base b of 2. And we know what the log base b of 2 is, so you would end up with 2 times 0.3010. And you can kind of do that one in your head, because 2 times 3 is 6, then a 0. 2 times 1 is 2, then a 0. And you're done. That is the log base b of 4, based on your properties. You're going to do exactly the same thing here. Now 125 breaks down into 25 times 5, and then 5 times 5. So log base b of 125 is log base b of 5 cubed. So the 3 would come out front again, and you'll end up with 3 log base b of 5, which is 3 times 0.6990. All right, I really don't want to do that one in my head. I guess you could, or you could do it. You could do it by hand, but if you've got a calculator standing by, then it makes sense to... Okay, that was strange. Right here, we've got the 2 log base b of 5 minus. Now, this is actually the whole log. So when I multiply this out, I should have minus log 2 and minus log 3. Okay? So this would be 2 times the log of base 5 here, like base b of 5. It's 0.6990 minus log base 2 is 0.3010, and log base b of 3 is 0.4771. So I would subtract all that. Okay. Move it over here. Going to have 2 times 0.6990 minus 0.3010 minus 0.4771. That's going to leave me 0.6199 as the log base b of 25 over 6. So we got it here, the log base b of the cube root of 5. So you've got to remember what a cube root is, and that's actually a rational exponent, 1/3. So this would be 1/3 of log base b of 5, which would be 0.6990 divided by 3. And this is one you can do in your head too. 3 into 6 is 2. 3 into 9 is 3. 3 into 9 is 3. And 3 is 0. So that would be your final answer. When you've got a log base b of a number, you really have to pay attention to those properties we had back in the first video that we've been using all the other videos too. All right, a question for your notes quiz. Here you're going to be trying them. If log base b of 2 equals 0.3010, use the same numbers. Find log base b of 16, log base b of 8 over 25, and log base b of square root of 2. So this will be on the notes quiz also for you to do. Make sure you go back and pay attention to what we've got. Okay, so a spacecraft can attain a stable orbit at 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. The formula for a rocket's maximum velocity, v in kilometers per second, is v equals negative 0.0098 t plus c. The booster rocket fires for t seconds. We need that. We'll get that. C, L, and R, excuse me. Okay. And V, we got. Okay. Velocity of the exhaust is c, kilometers per second. The ratio of mass of the rocket filled with fuel to its mass without fuel is R. Suppose the rocket shown in the photo has a mass ratio of 25, a firing time of 100 seconds, and an exhaust velocity as shown. Okay, there's your exhaust velocity. Can the spacecraft attain a stable orbit 300 kilometers above Earth? So you've got negative 0.0098 t plus c, ln, r. And they've got everything for you to fill in. There's your t, there's your c, and there's your r. So you fill it in, that times 100, 2.8 times the ln 25, which is 3.219. And when they do it, it's about 8. The maximum velocity needed is 7.7, so the answer is yes. Just got to know what it is they're looking for. Okay, this right here is logarithmic function graphs. And here you can see it's exactly the same thing we've had before. This is all transformations together, but the a in front, it's a stretch if the a is greater than, because it gets thinner and flatter. Compression if it becomes kind of up like this. It's a reflection if it flips over the x-axis or if it flips over the y-axis. There's your parent function. So all of this is nice to have down, but you have not, it's nothing different than what we've done if you've got the basic graph. These are inverses of each other because as you can see, they are reflections over the y equals x line. So that's it so far. The big thing on this is your properties of logarithms and being able to use them. So I'll see you in class.